As we learned in the previous lesson, an account script conditions must be fulfilled before any type of outgoing transaction can be made. For instance, the script defines those users who can sign outgoing transactions. This is a critical moment because it's the most common point for security vulnerabilities. We're building a decentralized Web3 coupon marketplace named Coupon Bazaar. So let's try to apply all we know about smart accounts to our application. So users should be able to search for discounts on goods and services, and they should be able to buy these for a small price on the marketplace. So each coupon is a digital asset that represents a special discount from the supplier. As a marketplace, Coupon Bazaar should provide matching and payment operations and set up delivery services between suppliers and customers. In the simplest implementation, which is also called the minimal viable product or MVP, we need the following features for suppliers. First of all, they should be able to register in our system, so a supplier registration system is required. Also, they should be able to manage items, remove item, delete, change the description or any other fields, and they have to confirm all purchases. The basic operation for customers are very simple. They should be able to find coupons and purchase that coupons. So, we're doing all of this on the blockchain, and we are going to store all the data on the blockchain, not in a centralized database. To save all the details about suppliers and items, we will use the built-in data storage available for all accounts on the Waves blockchain. So in other words, every account has its own key value data storage, which allows us to write data using a special type of transaction. These are called data transactions. How we can use smart accounts in our application? The very basic and simple way is to allow data transactions for suppliers, because they should be able to update the data about their items, and deny all other transactions except setScript transaction. Why we make that exception for setScript transaction? Because it is required for us to update the smart account logic in the future. So here's a simple code. Please pay attention to the vulnerability in the code. At this point, any user is able to sign outgoing transactions and even update the smart account logic. So anyone is able to change the account script on this account and withdraw all funds. So in order to allow only the DApp owner to change or update the script, we should use the function called SigVerify. Using this function, we can check that a signature from an array of signatures called proofs belongs to the DApp owner. Let me explain it. Every transaction has a field called proofs. We store there up to 8 signatures. So in the smart contract code, we can check that one element from this proofs array is a signature by this public key. So in this case, we will say that first element of the proofs array should be a signature from the app owner. And we can use the SigVerify function in the pattern matching construction within the verify function. I'll explain all this stuff a little bit later. So SigVerify returns a Boolean true value when the DApp owner signs the transaction and false otherwise. Let's look at the classical example for smart account usage. To increase the security for digital asset storage, many people use multi-signature accounts or multisigs. Let me explain what is it. Let's assume that our suppliers are small businesses consisting of several founders or administrators, for example, 3. We will case 3 is our case. To withdraw funds from the multisig account, at least 2 out of 3 signatures are required. So we will require two persons to sign a transaction, and only after that the blockchain will be able to perform an outgoing transfer transaction. So this multisig account also protects the online store from hacks when an owner's private key or seed has been compromised or stolen. To implement a multi-signature account with at least two signatures, we should declare the public keys of the valid account signatories. Check the validity of signatures in the proofs array against some defined public keys, and return a Boolean value depending on the number of valid signatures. So participants should be able to sign transactions in different orders, so all combinations should be checked.